Good morning, students. Today I am going to discuss regarding to effective resistance in series connection. So, to calculate effective resistance in series connection, try to see the diagram. When the resistors are connected in a series, then if there is a resistor having a two terminals, that is the first and second terminal, then second terminal of a first resistor R1 is connected to first terminal of a second resistor. Likewise, if the resistors are connected, then we will call it as a series connection. So, if this is a resistance is R1, this is a R2 and this is a R3, then these resistors are connected with a battery of a V volt battery is connected in series with the switch, and to measure the current flowing through the circuit we connect ammeter, that is A is ammeter, and to measure the potential difference across the first resistor, here we connect voltage measuring device voltmeter. To measure the voltage drop across the R2, we connect V2 voltmeter. Here it is a V3 voltmeter to measure the drop across the R3. To measure the whole voltage drop, we connect another voltmeter V across these three resistors. See, whenever switch is closed, when switch is closed, I current is a flow through the circuit. This I current is comes here. Here voltmeter having a high resistance in series. So current always chooses a low resistance path and it travels through the resistor R1 I current. Again it comes to this point. Again these are the voltmeter terminals. Current will not flow through the voltmeter terminal and it flows through the R2 resistor. And then it is through R3 resistor same current and it travels I current, and likewise current is flowing through the circuit is same. So we can say I is same in all resistors in series connection. So current I is same in all resistors because only one path of current flowing is there. If the current path is a one path, then current is same. It is not dividing at any point. Then here this battery is use energy, that is a potential energy to these resistors. Then first resistor R1 is utilizes some energy and dissipate in the form of heat and light if in case it is a bulb. Then we can say here R1 resistor is utilizes some energy, then there is some energy drop is there. So that energy drop will call as a voltage drop across the R1. So here voltage drop across R1 is V1 is equal to, according to Ohm's law, voltage drop across the R1 is, we know V is equal to IR. By the Ohm's law triangle you can see this is a voltage and this is a current and resistor, both are in multiplication. V is equal to IR. I is a current flowing in R1 resistor, then it is a IR1. Next, voltage drop across R2 is V2 is equals to I into R2. Similarly, voltage drop across R3 is V3 is equal to I into R3. See, V potential is given to these three resistors, then voltage across this meter through this resistance is measured by the voltmeter V1, and voltage measured by the V2 across the resistor R2, and voltage measured V3 across the R3. Those are numerically equal to I into R1, I into R2 and I into R3. The whole voltmeter is measures the voltage drop across all the resistors. That is all resistors voltage drop is V1, V2 and V3. Sum is measured by the V voltmeter. So voltage drop across all resistors, say as R effective is V is equals to I into R effective. So total voltage or voltage drop is equal to I into R effective. That V value is, we can say that V is nothing but, we can write here, voltage, total voltage is equals to sum of voltage drop across V1 plus V2 plus V3. Voltage drop is V1 plus V2 plus V3. Already we know V1 stands for is I into R1, V2 stands for I into R2, V3 stands for I into R3, and V stands for I into R effective. Then I into, we can write I into R effective is equals to I into R1 plus I into R2 plus I into R3. Over here I is taken as common, then we can write I is taken common, R effective is equals to I of R1 plus R2 plus R3. So I and I gets cancelled, then R effective is equals to R1 plus R2 plus R3. So this is the effective resistance when the resistors are connected in a series connection. Over you can see here clearly, total voltage drop across three resistors is nothing but a sum of voltage drop across the 3 voltmeters. That is done here. V is equal to V1 plus V2 plus V3, and already we know the voltage drop across each resistors. That is V is nothing but I into R effective. V1 stands for here already we calculated I into R1. Here V2 is equal to I into R2, V3 is equal to I into R3. Those I substituted over there, and at last current in left hand side and right hand side is similar, that is cancelled out, and total effective resistance we got it as R effective is equals to R1 plus R2 plus R3. Next equivalent circuit to the given resistors is nothing but equivalent circuit is equivalent circuit. These three resistors are replaced with a single resistor R effective. These three voltmeters are replaced with a single voltmeter V, which are connected with a battery and single ammeter and switch. So this is nothing but R effective. R effective is nothing but sum of all resistors in a series connection. So you can clearly see that the effective resistance, or you can draw this voltmeter up also. So note not difference, anything similar. So the equivalent circuit for the series circuit is nothing but R effective is connected with the battery and the switch and the ammeter. That effective resistance is the sum of all resistors. So this is how we measure if three resistors are connected in a series connection. So if there is more than 3 resistors are connected in series connection, then if there is n resistors are connected, then total resistance or effective resistance is nothing but we can say R1 plus R2 plus R3 plus and so on Rn resistance. Sum of all resistors is nothing but effective resistance in series connection. Coming to the, if there is a number of resistors resistors which are connected in series, if all are same, then effective resistance is nothing but we will add them all resistors and number of resistors how many they are, and we will multiply with that is, and we will write those things in a note point. Look at here. See the note. See, when number of resistors are connected in series connection, then effective resistance in series is equals to sum of resistors R1 plus R2 plus R3 and so on. How many number of resistors are connected? Like if this is a first resistor R1 and there is another resistor is R2. If there is another resistor R3. So like many resistors are connected, the effective resistance of all the resistors is nothing but sum of resistors. Okay, coming to the next one. If resistors are R1 is equals to R2 is equals to R3, all are equal resistors are connected in series, then and so on Rn resistors are connected, all are equal to the sum R. Means like a 3 ohms or 4 ohms. Likewise, if there is a resistors are connected, all are similar, then effective resistance is Rs is equals to R plus and so on n times R. If n times R is there, like 5 resistors are there, R plus R like 5 we will add, so 5 into R we will write. Here n times we are adding, then R is n times means n into R. So if there is each resistor of like a 2 ohms, like example here each resistor of 5 ohms are connected in each resistor of 5 ohms connected in a series each resistor of 5 ohms are connected in series of number 20, then R effective is, see each resistance of 5 ohms are connected in series, okay, then now each of they are numbering 20, then R effective is, so R effective is what, then R effective is equals to R into N into R we can write this formula. So over N is equal to given 20, R is equal to given that number of resistors, each resistor value is 5 ohms, then R effective we can write here, R effective is equals to, R effective we can write as here 20 into 5, so we can write as 100 ohms. So effective resistance is nothing but 100 ohms when the 20 resistors each of 5 are connected, 5 ohms each are connected in a series connection. So let's we will go with 3 resistors of each 10 ohms, 20 ohms and R ohms are connected in a series connection, then effective resistance is 100 ohms. Find R is equals to how much? So the question is very clear. They given 3 resistors, each of 10 ohms, 20 ohms and R ohms are connected in series. The effective resistance is 100 ohms. Then they are finding what is the value of R. So you can see the solution over there. First, whenever any question is given, try to write the given data. So R1 is equals to, we can say 10 ohms, R2 is equals to 20 ohms, R3 is equals to, it is R ohms. R effective is given in question, that is 100 ohms. So we want to find the value of R. If you want to find the value of R, we know the effective resistance formula. that is R effective is equals to R1 plus R2 plus R3. So R effective is known, that is 100 ohms. Don't write units while substitution, just write the numbers. So here 10 ohms is R1 plus 20 ohms plus it is R ohms. Ohms no need to write. Okay, so these two together 30 will to this side. So 100 minus 30 is equals to R. So after subtraction we will get R is equals to 70 ohms. So at last we will write that one point here. The resistance value, the value of resistance R is equal to 70 ohms. So this is how we will solve the problems in a series connection. So if any question are possible to ask on the only two formulas, one formula is in a series connection R effective is equals to R1 plus R2 plus R3 plus and so on. This is one formula. Another formula is R series or R effective is equals to, if there is R are equal resistors, so then N into R. So these are the two formulas which are used to calculate any series connection of resistors are given. So with these two formulas, any question we can able to solve. And major point we have to remember, when current flowing through the resistors is same, then we have to solve that connection first. That is a series connection. When current is same, current I is same in resistors, then they are in a series connection. See, this point you have to remember, among all points this is very very important. This point, when current flowing through the same some resistors, when current is I same in resistors or current is flowing through resistors is same, then we will say they are connected in a series connection. This is very very important. While solving the problems, we have to see this point is very important. After knowing or confirming this point, then we use these formulas whether they are in a series connection or any other connection. So this is about the series connection of resistors. Thank you.